To optimize your process, it means that you want to know what is the optimum amount of oil, the optimum amount of ethanol, of catalyst, and so on to get higher yield. And this is what basically our friend did last year. They got an optimum around 7% catalyst loading, and this is what you are currently using. This is versus the yield. And for all of you guys, you must know also how to determine the yield of your reaction. And you saw it in Chem-Tech too. And for the temperature, they got to the conclusion that the maximum, the ratio which was favorable for the higher yield, it was around 25. In terms of mole, 25 alcohol and 1 mole for your oil. And they got a yield around 97%. And looking at the reaction time, they got to the conclusion that the higher yield was obtained after 3 hours. So after 3 hours, it was not necessary to continue, okay, to carry on with your reaction. And after optimizing all the conditions, they got now the biodiesel. Now look at, how can you convince now people that what you do here is a biodiesel? It's like our friend working with solar panel. How can you convince people that it's a solar panel? You're going to just tell people, come, let's go to the sun. Okay? Or bring your lamp and you connect. Just to show to them that it's working. Now in your case, you do have biodiesel. Before to put it in the car, you need to analyze. Okay? According to the standards. One of the analysis you're supposed to do is what we call the GC analysis. The GC analysis gives to you, these are the responses you get from the GC. When you inject your biodiesel inside of your GC, it will burn. After burning your hydrocarbon, it will. Bear in mind, we said that your palm oil is made mainly with we say that the palm oil is made mainly with 3 types of acid. The first one we said is palmitic acid. Palmitic acid, which is more or less 48%. The second one, oleic acid, which is more or less between 20 and 25%. And the third one, linoleic acid, which is more or less 30%. Now look at, when you make now your biodiesel, and the rest are just traces. When you make your biodiesel, tell me, because your GC will give you the intensity of your area versus the retention time. So the retention time here is, it depends on the length of your molecule. The shortest one has got the small retention time. Let's say, for example, if your sample was made with methane, propane, and so on. If you inject this in your GC, which one will come first in terms of the retention time? Is it going to be methane or propane? It's going to be methane. Are we together? So the first one is going to be methane, then propane. But you should have on your GC two main traces, except the eluent. The eluent is like a solvent. If you want to see your peaks, you must dilute your biodiesel in a certain solvent. And the big one you see first is your solvent. And this is basically what appears here. This is the peak of the solvent. But forget about the solvent. It's the rest which which is more interesting for us. Let's say in the case of your biodiesel, how many main peaks are you expecting? 3. Are we together? So that's here, you got the first one, the second, but here is not even clear. Let me check what they got here. I believe I do have the results. Good. Good. Guys, this is what they got as a result. This is what they got as a GC results. They got the first peak, the second, and the third one. You can even read from the areas they obtained here. They got 3 peaks. What does it mean? This is an indication to show to you that what you obtain. It means that your alcohol and your catalyst played, truly speaking, the role. Are you with me? Otherwise, if it was still palm oil, how many peaks are you supposed to have? How many? 1. Are we together? So this is one of the analysis which is done to confirm the composition of your sample, and to do also what we call the quantitative analysis, because it gives you also the proportion of each constituent in your sample of your biodiesel. And this is what our students did last year. All right, I would like just to say this. Here they made also a comparison. This is the result, and the top one, it was made by other people. When you get your own results, some other times it might be good to compare with what other people have already done, just to see if there is certain correlation. After finishing with the GC results, we went now to the characteristics. Guys, if you do have your gasoline, your diesel, whatever you want to use in the car, there are characteristics that people are supposed to look at. The first one is the density of your fuel. Is it okay? The second one is the second number. The third one is the kinetic viscosity, the flash point, and the heating value. Now, you must always have a standard. It means that if you look at from handbooks or from different references, they gave the values within your value supposed to fall. Otherwise, you are in trouble. Because those people are in contact with the cars producers. If your biodiesel is not complying to the standards, they will advise those people to not use them in their cars. And they will say, guys, be careful with those producers. Are we together? And you must convince those people. And the standards are there. These are the minimum, these are the maximum for the biodiesel. And after analyzing for our biodiesel, the density we got is 871. The minimum is supposed to be 860 and the maximum 900. What does it mean? It's falling in between. Is it okay? For the certain number, the minimum is supposed to be 51. The current diesel, the one sold in the station, is 49. Ours is 56. What does it mean? Are we together? Good. And the reason for this, it's very simple, as I said to you. The current diesel is a mixture. Are you with me? The mixture from C11 to C19. But for us, it's between C15 and C17. Are you with me? This is the reason for ours to be higher than the minimum one, than this the diesel from the fossil. When it comes to the viscosity, the range is supposed to be between 3.5 and 5. Ours, it was 381. What does it mean? It's falling within the range. But the current one for the diesel from crude oil is between. Though this is not falling in between. Okay? But for the standards, for the fossil diesel, it is good. The flash point is 120. And for the diesel, from crude oil is 55, but for us is 175, 157. Which one is good? The minimum here is 120. Ours is 175. For the diesel from the crude oil is 55. Which one is good? But you need to understand now what is the flash point. Okay? The flash point, as we discussed from the beginning, is the temperature at which the vapor emanating from your fuel can get the flame. Are you with me? So it means that if you leave the diesel here, you can see the flame coming out, isn't it? But that flame can get flame, that vapor, sorry. That vapor can get flame. It can give a flame at 55 degrees C. But for the biodiesel is at 157. Which one is more dangerous? It's okay? However, you have to play between these parameters, certain number, flash point, and heating value. Okay? Because someone else may say, okay, it can burn easily. So you have to play, okay, between those parameters. But based on the safety, this one is more safer than the current one. And the heating value is 32, and here it's 40, 43. Eventually, if this could be improved, it can get higher. Because if you compare the GC traces that they did last year, you will see that they got a lot of impurities compared to what they are doing now. Definitely, it will improve a lot of parameters. Okay? Good. And to determine these parameters, it costs a lot. It costs a lot of money. If you go in DRC Congo, Cameroon, I'm not sure, Angola they should have equipment because they are producing petrol. But in other countries, they don't have equipment to determine those parameters. That's why when we're going to be in Congo, we're going to keep in touch with some of you guys so that we're going to be sending samples so that they might be analyzed here in South Africa. Are we together? Good. However, beside the samples that you can send outside to be analyzed, you can determine those numbers empirically by using those formula. Let's say, by example, for a certain number, this formula has been developed where M is standing for the molecular weights of the biodiesel molecule. So, N is standing for, people working on that, N is standing for? Number one, the composition of your biodiesel, you should be able to determine the certain number. Before even those people, because when you send your sample outside, I think last time we went to with Fabrice, when you send your sample outside, those people, I'm not saying, I'm not a racist, but I would like just to say, some other times they think when they're dealing with black people, we can just do that. You can check if the result they are giving you is correct or not. Are we together? Please don't shoot what I say, okay? You're going to cut that.